Hello, Elizabeth and Miriam and Ellie and Sam. This is your Precalculus class for March 23rd. I hope that you all and your families are well and safe during this time of health crisis. This is my first attempt at a teaching video, so hopefully this goes well. Hope that you'll be able to read the board and we'll be able to hear my voice clearly. I said this is your class for March 23rd. We have just ended the third quarter. We're just coming off a spring break. I will give you instructions in the email that I send with the link to this video on what to do with your test and your homework that is due to me. But for this week, the week beginning March 23rd, we will have homework per the syllabus. We're beginning a new chapter, chapter 6 on trigonometry. So we will have lesson 6.1 this week. For the syllabus, we will do the odd problems in part A. We will do the odd problems in part B, skipping problems 17, 19, and 21. I will also send out a quiz over lessons 5.3 and 5.4 for you to take this week, in addition to the homework over 6.1. We will not be meeting face-to-face for the help session on Wednesday, so any help will be done by phone. Please call me or email me if you have questions. I can attempt to answer things via email. We can talk on the phone. We can do a virtual meeting if you wish to try to look at things together. We'll just kind of figure out what the best approach is for help going forward here. But again, for this week, we're starting this new chapter 6, the study of trigonometry. Trigonometry is primarily the study of the measures of the three parts of a triangle, the three sides or the three angles. So we will be studying two different aspects of trigonometry. One is that relationship between the sides and the angles of a triangle. So we will be solving triangles, which means that we will be finding the lengths of all three sides and the measures of all three angles. So we'll be solving triangles. We'll also be looking at how trigonometry describes periodic behavior, like circular motion and waves and AC current, alternating current in electricity, the motion of a pendulum back and forth. So trigonometry can be used to describe those periodic motion, periodic behavior, and we'll get into that primarily in chapter 7. But we'll look at the unit circle and how it describes that behavior as we get to those lessons. But for now, our focus is on triangles. Again, for a triangle, we're going to be looking at the lengths of the three sides and the measures of the three angles. So there are 6 parts of the triangle that we're going to be solving for. We're going to use this typical naming convention where we label the angles as capital A, B, and C, and then the side opposite the angle is going to be lowercase a, B, and C. So for side A is opposite angle A, side B is opposite angle B, etc. Okay? So again, in order to solve a triangle, we're going to find the measures of all 6 of these parts. 2 angles are considered to be congruent or the same if all 6 of those parts are the same. So if lengths of all sides are the same, or the measure of all angles are the same, then those are 2 congruent triangles. Triangles are considered to be similar if the ratios of the lengths of their sides are the same. So if the ratio of A to B, or B to A to C, B to C, if those ratios are the same, it's a similar triangle. So as we expand this and keep the angles the same, or shrink it and keep the angles the same, we have an infinite number of similar triangles. This lesson is going to be primarily a review of geometry of triangles. So it's going to be a review of the geometry class that you took a couple years ago as freshmen. I'm going to keep this video pretty short. I'm going to hit the highlights of the lesson. So I would encourage you to read the lesson carefully. The lesson will go through the various geometric cases and the constructions of those cases geometrically, because the focus of this lesson really is going to be if we know 3 of the 6 parts of a triangle, does it uniquely define a single triangle or not? So that, again, should be a review from your geometry class 2 years ago. So we're going to look at those cases where I'm given 3 pieces of information. Am I given enough information that it defines a single triangle? And can I take that information and find the other 3 parts of the triangle, solve the triangle? So there are 4 cases that uniquely define a single triangle. The first case is side, side, side. If I know all 3 sides of a triangle, then the angles are locked in. There is only one triangle that exists if I know all 3 sides. So I can draw that triangle and I can solve for the other 3 angles. And again, in your lesson, in your text, they'll describe the construction of that geometric case and why it uniquely defines a triangle. So I'd encourage you again to read through those just to refresh your memory from geometry about how these different cases work. Okay, so these are the unique cases. Again, they define a single triangle. Second case is side, angle, side. So if I know 2 sides and the angle between them, so for instance, if I know side C and side A and I know angle B, then that uniquely defines this triangle. I mean, if you just think about that from a geometric standpoint, if I know these 2 sides and an angle, that uniquely defines where these points are, A and C, the vertices, and how long that other side needs to be. So if I know these 3 pieces of information, again, unique triangle, and I can solve for the other 3 parts. Third case, angle, side, angle. So if I know, for instance, angle A and angle B and the side between them, then that uniquely defines this triangle. And again, I think if you think about it, again, look in your book, but I think if you think about the geometric construction of this, it makes sense. If I know those 3 pieces of information, again, a single triangle, I can solve for the other 3 pieces. And then the fourth case is angle, angle, side. So if I know angle A, angle B, and side A, then I've uniquely defined a triangle. I can solve for the other 3. These 2 cases are really the same as each other. I mean, you can derive each case from the other one because we know that the sum of the 3 angles in a triangle is 180 degrees. So as long as I know 2 angles, I can find the 3rd angle. If I know these 2 angles, I can find this 3rd angle over here. So those 2 cases are the same, and again, define a single triangle that I can solve. Okay? So what about the cases that are not unique? So these do not define a single triangle. Case number 1, angle, angle, angle. So if I know all 3 angles, I can keep those angles the same, and I can make bigger and smaller triangles. So this defines an infinite number of similar triangles. So this is the case where, again, the ratio of the sides are going to be the same, but it does not define a single triangle. And so if I know all three angles, I cannot solve the triangle. I cannot find the length of the three sides. Okay? And in the other case that is not unique or does not define a single, it might define one, but it doesn't necessarily define one, is the angle side. So if I know angle B, side A and side B, it does not define a single triangle. It can define two or one or maybe no triangles. Let me redraw this a little differently. Let's talk about this case a little bit. Again, he does a good job of describing it in the text, but I think this is fairly easy to see if I draw this properly. So if I've got angle B here, let's say that I know angle B, and I know side A, so that defines where C is, that vertex. And I know the length B, but my problem is I don't know this length C over here. So if I have a length B that goes like this, I can also have the same length B. I'm not drawing this very well, but I think you can picture that I've got two possible triangles here. So I could have an A here or an A here. So let's call this A prime. So this would be one length, C prime, and another length, C, that goes out to point A here. So I've got potentially two different triangles in this case. If I just happen to have a B length that hits in just one point on this side, then that would define a single triangle for me. So that is a possibility. But then I also might have a B length that is too short to reach that side. So that would be no triangles that it defines, okay? So the problem is, if I have this case, it's ambiguous. Okay, this case I can't solve at all, but the angle side case is ambiguous. I don't know if I have no triangles defined or one triangle defined or two. So when we're solving triangles where we only have this information, we have to be very careful about how we do it. And there are things that we can do to use the trigonometric functions, use the trigonometric laws like the law of sines and the law of cosines that we're going to be using to solve these triangles. So there's just some things that we can do as we solve to be careful and make sure that we come to the right conclusion, okay? And sometimes you just don't know enough information, so we'll have to figure that out too. And that's the focus of this lesson. You're not really going to be solving triangles in this lesson because we haven't covered the trigonometric functions or the trigonometric laws yet. We'll do that in lesson 2 and lesson 3 of this chapter. But for this one, it's really a review of these geometric cases and really knowing whether you have a unique triangle or not based on the information that you have about the triangle. So the other thing that you're going to do, so you're going to be using this fact about the sum of the angles being 180 degrees to solve some problems. You're going to be using Pythagoras. So if I've got a right triangle where C is my right angle, so I've got A, B, C. So small c is my hypotenuse, B is the length of one leg, A is the length of the other leg. We know from Pythagoras that A squared plus B squared equals C squared if and only if angle C is 90 degrees, right? Because remember, the legs are the sides on either side of the right angle. So it's A squared plus B squared, and C is my hypotenuse, equal to C squared, okay? So you'll be using the Pythagorean theorem to solve some problems also this week as a refresher on that. So again, this lesson, just refreshing geometry, remembering these facts about, in this case, a right triangle, in this case, any triangle. And then in later lessons, we'll learn the law of cosines, or we'll review the law of cosines, which extends the Pythagorean theorem to enable us to solve triangles that are not right triangles. So that's it for this week. Again, I hope you all are well. I hope you're safe at home and isolating and washing your hands and all those things that we're supposed to be doing. Have a good week. Take care. And I'll be sending another video out for the next week. And then hopefully we'll be back at Mars Hill before too many weeks pass by. Take care.